forensics means to be specialized. Here is a specialist. What is your name?
My name is Helen Brandt-Latovic.
Hello, Helen. So you're a specialist for the surfaces of joints, as I understand it. Please explain.
So essentially in my research here, I'm looking at the sacroiliac joint specifically.
Where are they?
In the hips.
The hip joint.
The hip joint that connects basically your torso to your legs. And so I'm looking at the similarity of the joint surfaces in order to say, can we identify if the joint surfaces are too dissimilar to say they come from the same person, or are they essentially similar enough to identify that, yes, they're from the same person.
So how many points did you measure? It looks like many points.
So this one, I use the curve tool. So a curve has 3 points in it. So I put 8 curves around it, so 24 points. And so I can use that to then compare with, this is the pelvis, compare with the sacrum, and then show that they're either similar enough to potentially say they came from the same person, or dissimilar enough to say that we can maybe exclude it as a potential match.
So that is probably not a problem in a hospital, so you're applying that elsewhere, I imagine.
Yes, to commingled human remains.
So, for example, mass graves? Or...
Yes, exactly. Mass graves, it has bioarchaeological applications as well. Essentially in any circumstance where you're not sure, if you're trying to exclude potential matches and saying that this pelvis came from this person or not, especially in forensic anthropology, this is really useful in reducing the number of samples you need to submit for DNA analysis, which can be very expensive. So it's a lot easier to be able to reduce the number of matches and then submit for identification later.
Why did you decide for this particular joint? Because there are many joints in the human body. Let's say you have a mass grave or something.
Right, and this is only one of the joints, sure. So this method works best on joint surfaces that are similar in shape. So the sacrum has this L-shaped auricular surface, just like in the pelvis. So that's why I chose that for this method. I'm also going to be expanding this for my dissertation and using the first tarsometatarsal joint and then the
Where is that?
In the foot. And then the atlantoaxial joint, which is one of the joints in the neck, both of which have similar surfaces between the two bones. So if I use something like the shoulder joint with your humeral head being round and the glenoid fossa being kind of teardrop shaped, they're very different shapes. So all this would tell me is that the two shapes are too dissimilar. So I needed two shapes that were essentially the same shape so that I can analyze how similar they are.
Do you need clean bones, or can you also do that on a, I don't know, CT or MRT or something like that?
I could use a CT scan, certainly. I wouldn't use bones that hadn't been processed or at least were able to be looked at radiographically.
You would not?
Not unless they had been scanned, like with a CT scanner or something like that. And then you can make virtual models from CT scans. I used a structured light scanner from clean bones to create my 3D model. So it just kind of, it would depend. You know, if you wanted to use a structured light scanner, you'd want to have clean bones, but you could use CT scans and convert them into 3D models as well.
What does your family and friends think about that work? Do you talk about that during parties? Is that a conversation piece or not?
Not really. They think it sounds really cool on paper, but then when I try to explain it, they just kind of glaze over and then they change the topic.
What's your recommendation once the glaze comes up? Do you already know that you should better switch the topic and change the topic?
Yeah.
Or did you ever try to convince them that it's something they should dig deeper into?
I try to talk about the broader applications of it, the humanitarian reasons why you might want to sort commingled human remains, and the importance of identifying them to return to the families, and those kind of broader issues that I think everybody can understand regardless of an education in forensics.
Let's say somebody is very young and wants to be a forensic anthropologist. Would you say that this is really tedious nerd work, or would you say, well, since there are broader applications, it's something that is also very social and good for the society?
Right. It's definitely very social. For me, this is my way of wanting to contribute to the general population. I think it's really important to identify remains and repatriate them back to their families and being able to give them that closure that, yes, this is your person and these are, you know, all the remains we could identify. So for me, that's what drew me into this field, and it's what keeps me going today, you know, in spite of the long amount of time I've been working to get my degrees.
So are you going to be a forensic anthropologist in 10 or 20 years? What do you think? Or are there other possibilities to apply that? let's say in a hospital environment or something like that?
Maybe not with this specific research in a hospital. Generally, you know who the person is at that
You're not disassembled in a hospital.
Yes, you're so big. But I do hope to, at least in 10, 20 years, have my PhD at that point, and then, go along and continue to be a forensic anthropologist, or at least work tangentially working with humanitarian organizations, things like that.
Yes, we wish you very good luck, and I know how much work this is, so if you want to be a forensic anthropologist, you need to be a nerd, even though she thinks she's not, but it's probably necessary. Thank you very much.
Thank you.